Okay, so the first section is really more conceptual. Just kind of asking, and we're not. I mean, if you want to, we can, but you really don't have to work this out. So they consider the following problem. Sure. Y'all can see the homework, right? You said.
Yes.
Yes, we can.
Okay, so find the distance traveled in 12 seconds by an object traveling at a constant velocity. So this is the big clue. If it says constant, it's most likely going to be like a a slope or a linear type of approach. So you don't really need calculus. So if your velocity is changing a lot, or the velocity is a function of something, then we need calculus. So this can be solid pre-cal or basic algebra. Just really depends on what we're talking about. If we're talking about angles or cyclical stuff, then yeah, sure. Um, no big deal. Number two, yeah, let's look at number two. Find the distance traveled in 15 seconds. So check this out. The velocity is now a trig function. It's not constant. So right away, that should be a clue that I need calculus, right? I want to find this. Now, in 15 seconds, let's see here. Well, this is going to be solved across use a graphical and numerical approach to estimate the solution. Okay, well, let's graph this guy to see what's going on. 20 plus 7 cosine. So x is, so actually it's t, but that doesn't matter. Let's just assume that x is our time variable. 15 seconds. All right, well, what's happening at 15? Okay, so our output is 15. Let's see. Stop, stop. Oops. Hold on a second. Times. Oh, I see. So that's going to estimate the approach. So if that's the velocity, we know that cosine, if y'all remember your trig, right? Cosine is always between 1 and -1. And
Yes.
it cycles forever, right? So if we estimate 15 seconds goes by, 15 times 20 is just going to be 300. Give me a moment. So this is the distance. If I were to find the position, well, I hate to do it this way, but if I were to disregard this guy here for now,
Yeah, that's what
I'm
I
only
did.
looking at the 20. This is only adding and subtracting 7 as time goes by. So I would have to find the original function, but I can't do that without using high-level calculus. So if I want to kind of cheese this, let's say every second I'm getting 20, it should be about 300. Let's see how they approach it. So it's 15 times 20 is 300, right?
Yes.
So let's see what they did. So that's the approach I would take, but it's whenever they say estimate, it's like, well, it's not, I can't use what I'm supposed to use. It's still too early. So velocity is not constant, which that was clear. 20 feet per second for 20 seconds. Yeah, so ours is 15 seconds, so they're basically treating it like as every second goes by, I'm going 20 more feet. That's all it is. So if I overthink it, becomes difficult in my head, but if we just kind of wave it away, like an engineer, say, it's whatever, don't worry about it. But that's all it is. It's just multiply the 15 and the 20. That's all they want you to do. But I want to do a lot more, but we can't yet. But anyway, the concept is, right, can you determine when we need calculus and when we don't? Is it
Yes.
clear?
Yes.
And right here, this one's pretty obvious, right? You literally have a slope. So this is a constant increase. So we don't need calculus. It's not that complex. So as writing this path, decide whether point B is okay. So estimate the solution. Find the rate of change. So back in like basic high school algebra or middle school, the rate of change is just the slope. But when we talk about rates of change of any function, that's when calculus comes in. That's going to be the derivative of a function. That will be the rate of change once you use some formulas, okay? But since it's just a linear, we don't have to worry about any calculus stuff. We can see it right there. This is causing this slope, which is the growth, the rate of change. So we don't think too deeply. Okay. And there it is. So that's what's creating the growth. This one is a more complicated function, is not linear. So you can see it's increasing. Let me get some arrows here. You can see from here to here, we're increasing. And as once we pass that peak, we start to decrease. So the rate of change is not constant. It's not a slope. The rate of change is a different function. So whenever that happens, when you have an increase and decreasing, that type of stuff, well, you need calculus to figure that out. And if you, let me see here. So if you plug in 1, what would you get?
Well, in order to find the slope, we what the lecture videos told was to
Mhm.
use 2 points that are close to one, like 0.9 and 1.1 to and just plug those in, and then you'll get your two y values. And
Yeah.
the 1.1 and the 0.9, those are going to be your two x values. So you take the formula for slope, you plug those numbers in, and you should get 0.24.
Yeah, I think that is the only way without using calculus is to use, yeah, that method. Because once you plug in 1, you'll have your y value. So pick any number close and it'll be a rough estimate. So yeah, you're right. Because if they're really close, you're basically getting an instantaneous rate of change. So that would be the best approach without derivatives. Alrighty. But man, thanks for reminding me. That's a very good point. Okay. Um, this is usually like at the end of Cal 1 or at the beginning of Calculus 2, we talk about areas and in integrals and integration, which is basically antiderivative because we want to find the areas underneath curves. But if the curve or the graph is very simple, geometrical, right? This is just a triangle. So find the area of the triangle and you'll be fine. So we don't need calculus for part A. Part B is not a simple shape, so you would have to use calculus, but let's see what they ask us to do here. Mhm. Oh, here it is, part B. Yes, this requires calculus. Yeah. So basically, they want you to estimate using a rectangle. So, like, well, suppose you could draw it here or something, or maybe
Yeah.
up here. It's the best we can do without any actual integrals. That you see how what they're trying to show us, right? They want you to see why we need calculus.
Hmm.
We need those answers, especially if these functions are like something really important, like velocity or some sort of force or profits or whatever. Then we care. This is a similar idea, but I'm gonna move on now. So that's all. What I want you to get from the first homework is, can you tell when it's important and why we need it? It's the main thing I want. Okay, let me go back. So 2.2 is like the real beginning of test one. I'm not going to test you on anything from the 2.1. It's just more of a check this out. It's somewhat interesting. This is the stuff that you will be tested on. Okay. So the first technique for um, sorry, someone's calling me. One moment. First technique is to plug in numbers really close to the limit and see what happens. So first of all, let's graph this and see what this looks like. Figure out what's going on. Top was what? X minus 4 over x squared minus 5x plus. So you can kind of see what we have a problem area, right?
Yes.
What value is that? 1, right? That plug in 1, we're going to have a problem. Minus, because if you factor at the bottom, what is the factorization here?
Well, what I did was I did what was called the checking my notes here. I did what was called the numerical approach. So I just focused on filling out the tables by basically plugging in whatever X variable there was on the table to I didn't graph it or anything. I
Right.
just
No,
did
no,
what
you did it the right way. No, we're
yeah.
getting to that in just a moment. But first, we're going to talk about what is a limit. Like, why are we doing this? Like, why do we care about limits, right?
Isn't the limit is what it's approaching?
Yeah, so it's a value we can't plug in, but we want to know what happens at that value. So we create this definition that's complicated, but visually is very simple. We just find out what's happening as the function approaches it. What does the function do the closer I get to it? When I come from the right side, it's shooting up, right, to infinity. Come to the left side, it's shooting down to negative infinity. So at 1, we have an issue, but what is the limit, right? But they wanted to know what's going on at 4. 4 might also have an issue, but it looks like the factors will cancel. So we have a special case here. which we'll talk about later. But if we go to 4, you're technically undefined. But from the left side, I'm approaching number point 4, point 3, point 333, and then the right side I'm approaching the same thing, 0.33. So basically what we're going to do is plug in numbers closer and closer to 4 from the left side of the VAT function coming in and from the right side. And the definition says, right, if you saw the video, what if they're both the same, then the limit exists, and whatever you're approaching is the limit. So graphically, we saw 0.33, right? So to do this properly on your homework, we plug in this number into this function, see what we get, and you end up getting this. Plug in this one, you get this. And then you can see that this number is approaching something. So this is the numerical approach for finding a limit. And the limit is just a value you want that you approach from both directions and see what happens.
To solve for the actual limit, the function that it gives us, we just factor it. We just factor the denominator.
Yeah, eventually we'll have another technique where we can factor and cancel stuff. We'll have quite a few to find limits. The first one is this numerical approach. Another one is the graphical. But I like to put the graph no matter what, just so you can see it, right? We can see what's happening as they get closer to 4, right? And that's what these numbers are doing here. So does that make sense what the numerical approach is doing or what it's for?
Yes.
Okay, 1 second.
Yes.
Let me know if you have any questions. If not, I'll move on.
Now go ahead.
All right. This one's the same type of deal, but it is a special case. Let me find the rule. One moment. Let me find the rule. It's called, forget. This guy here. It's found with the squeeze theorem or sandwich theorem. I don't know if it has a name, but I treat it like a formula. So basically, whenever x is approaching 0 and you have sine x over x, meaning that the argument inside here is the same as what's down here, then it's equal to 0, equal to 1 when the limit is approaching 0. So this is something that you should have in your notes or on your formula card or formula page. I'm going to send you some formula stuff pretty soon, but you can kind of see it right here. Check it out. Notice it's approaching 0. So whenever I see sine and x and I see a 0, my mind's like, oh, there's a formula. It's been proven. So right here, that piece is going to go to 1, right? Based on the formula. So did we set the limit? Sine x over x. I mean, you're supposed to plug in the numbers, so we'll get to that. But I want to show you an analytical approach while we're here. So this whole piece goes to 1, but there's still a 3 hanging out. So it becomes 3 times 1. So you can actually calculate the limit right away by using the formula, by using this idea. So this is 3 I don't have to do all this, but let's say I didn't know the formula, I can, or I don't know what to do. Like, let's say I get a limit question and I just have no idea what to do, what technique to use. I can always plug in numbers and approach it and see what's happening. If the numbers go to two different places, then there is no limit. You would say it does not exist. So you can see right here, as I get closer from the left side, right, I'm approaching 3. From the right side, I'm also approaching 3. But with the rule, it was 3 to begin with anyway. And if you graph it, you would see it, right? I'm just doing all the techniques at once because I'm going to keep repeating myself. So it sticks. So as the limit approaches 0, we can see that it's going to 3 from the right, right? From the left, it's approaching 3. So both directions are approaching the same place. The function is not defined there, but the limit is going to 3. Therefore, since they are the same on both sides, as we saw here, the limit exists at 3. Is there any questions on number 2?
No.
No, sir.
Then let me know at any point. If I make no sense, just tell me. All right. Here's the same deal. They're approaching 3 from the left, approaching 3 from the right. Just plug in numbers. These are all basically calculator questions. Okay, that's all they are. This one, you can see it without, they basically graphed it.
Excuse me, can you go back to number 4?
Oh, yeah, sure. Uh-huh.
So I did when I used the my gravity calculator to plug in that equation, it came out as a it came out as a it didn't add up like
You didn't get
forgot
any
what
of these numbers?
but yeah. So I put do not enter and that turned out to be wrong. So how would you put it in the calculator, or how would you put it in the calculator?
Which calculator are you using?
TI 36X Pro.
Let me go get a calculator. Hold on a second.
That's the same one I'm using.
One moment.
Yeah, when I
That's
plugged in that equation on my calculator, it said, hang on, I'm pulling that up.
Is it on radians?
Yeah, it said a divide by 0 error when I plugged it in.
Mm.
Maybe
On
switch it to
It
degrees.
is on actually it is on Radiant.
Maybe you
Yeah.
should switch it to
With the
degrees.
degree, yeah.
Oh. Because of the E? Yeah. Okay, thanks. I just want
Yeah,
thanks for
switch.
clarifying that, guys. I've yeah, I
'Cause
haven't been calculus in 5 years, so I'm still learning all this stuff, relearning everything.
You're using the same calculator as mine. You just have to change it because mine is fine. I got the answers.
Well, thanks for clarifying that. Like I said, it's been 5 years since I took free calculus, so I'm still figuring out how to readjust to this calculator, you know?
That's why we're here. We're all learning.
Oh, it's still not working. I set it to degree and it's still not working. Divide by 0 error.
What do you have X set as? Do you have X set as 0 on your calculator?
I didn't set up a 0. Because when I try to enter it, it says divide by 0. I got 3e x as a x squared minus 3 divided by x. Exactly how it should be.
Yeah, I'm saying that sometimes you can like enter into a calculator that X equals a certain number before you even enter an equation, and the calculator will save that. So maybe your calculator has 0 saved as X, and that's why.
All right. All right, I guess I guess I'll try it, but
What were your numbers? We can test it out real quick.
my numbers for this one were 4e x squared minus 4 over x.
For E X
Yeah,
X squared?
yeah.
Oh, okay.
I mean, not x squared, but x goes into the
Okay, but you have the same 0.1 and all that, right? So we'll put
yeah.
in there for now.
Did you
And what was
set?
the number? Minus 4 in the front on the side?
Yeah, your 4 goes right. My 4 goes over there,
Good.
divided by x.
All right, so I'm just gonna cycle the x's as I go. So this negative 0.1 is my first x. It's at the top. This is the bottom. Yeah, I got 3.8. What was their answer for the first one? Did you use an X or or did you just plug them in like this?
I used x for the config. I used x for all the configurations. I put x in where the negative 0.1 is and all that.
Did it work or was
Nope,
X stored as something?
it didn't work.
Yeah, I think you need a. Well, I'm not sure. I don't know. I don't know if you can create a function. Probably can, and use an X and then replace the X as you go. But usually I just plug it in straight up like this. That way I don't have to worry about because I don't know what numbers are stored in all these variables. So I'd say just do this and then just copy it again and change it to 0.001. You know what I mean? Just add it a little cumbersome, but
Well, it did. Well, it did work for me this time.
oh, I did.
Yeah, without if I
Use the
replace the
variable.
x with the if I replace the x with the numbers, I get it.
Yeah, that's the only way I know how to do it. If there's a function that you can create in here, then let me know. But I don't remember.
Yeah, well, I don't get. I mean, I didn't have to put replace. I used x for all the other ones I did, and the calculator accepted it. I don't get why it wouldn't accept this one.
Yeah, I don't know. I don't know. I always just type it in like this on the 84 and 83. But I am aware that you can use an actual variable. I just never do it. I don't remember how.
Okay,
But
I
anyway,
guess we can move on.
yeah, it's just a calculator question. I'm sure it's not your fault. Okay. Can y'all see the homework still?
Yes.
Yes.
Okay. So on this one is basically what we've been doing, but now they're forcing us to do it. So as I approach the limit value 2, which is right there from the left side, what are the y's doing? From the right side, what are the y values doing? Here's the value I care about. So what am I approaching?
1.
Yeah, you can see this side is going to 1. The other side, same deal. Closer we get. But we don't need all that because we can pretty much see it. It's defined, you can plug it in. It's going to 1, both sides, therefore it exists, and that value is 1. So we don't need to do analytical stuff. Also, when you plug it in, what do you get? Plug in 2.
You get 1.
Yeah, so You can literally just plug it in and get the limit. So the first thing you should do when you're finding limits is plug it in and see if you can. If you get an error or undefined, what that means, you should probably graph it and see what's happening around it. And if the graph is ridiculous or you're not able to graph it, then you go back to numerical, plugging in numbers and get close. Okay. All right. Let's check this one out. This is the piecewise function. So they purposely made a weird function to create this scenario because math likes to create a situation where it's not always true, right? So what's going on for this function f? The function is this entire graph. What's going on as x approaches 1? What is the limit?
Well, we should try reading the function first. So it says here, if x is not equal to 0, then x squared is subtracted by 2. So there really is no x-intercept here. So what the first function is telling us is that the y-intercept is at 2. So that's where center is going to be. Now, it then says if x equals 1, then just put it in -2. So that's where we know where one of the points are.
So the function is defined at 1, it gives us -2. So this is the defined point that's mentioned and that's right here.
Yes.
So, but notice that that's not the same as the limit, right?
Yeah, it's not.
So this is a special case where the limit exists and it is not equal to the functional value. As we approach from left and right graphically, what is the limit going to?
It's going to -1 on the y-axis.
Yeah, you can see right here, right? The y's are getting closer to -1, but
Mhm.
the function is actually -2 because of this definition right there. Later, we're going to talk about that as a not continuous, but the limit exists. Is there any questions on why the limit is -1? Do you see how they kind of try to mess with us with this?
Oh, yeah. No questions. Although the one that I got on the homework was not as funky looking as this.
Yeah. Okay. Well, let me know if I'm moving on. If you have a question at any point, you guys let me know. Number 7. Again, this is a kind of like a step function. Do you see why the limit does not exist?
Yes, because both of these lines are going infinitely towards the left and infinitely towards the right. So there is no limit.
Not necessarily. Anyone else have an idea?
Well, I just
I
can't find the
I
terminology.
I think it's just because they're going to two different points. They're not going to the same point, so they can't. They're two different things.
Oh, yeah, that's right.
Yeah, so the y values have to approach the same thing from both directions. So if they go to different places, that does not exist. The individual one-sided limits do exist. So we approach something different from the right. What are we approaching from the right? It looks like
Looks like we're approaching +1
in the
and we are approaching.
bottom.
Oh, from the right. Okay.
Yeah, right is
This one.
looks like no matter what, it's always going to be 1 from the right, and the
Yeah.
left is always -1. So
Mhm.
that's two different things. Doesn't exist at that particular value of -4. Does that make sense, everybody?
Yes.
Yes.
Okay. But if I would have picked the number over here, it would have existed, right? If x approached 5.
Perhaps. Yeah, it would have.
right? If I would have changed this to 5 right here, we'd be going to 1, right?
Right.
So it's just a specific one that had a problem. Any number I choose on this line would be approaching 1 as a limit. It's not until here it gets weird. It's another example where they're different, right? What's the right-sided limit? As x
0.
approaches 0.
0.
Yeah, as x approaches 0, we're going to 0. And from the left, we're going to
The 1.
1.
1. So they're not the same. So whenever they're not the same, the question does not exist. Now, if they would have had like in a moment, or maybe next time, if you see this notation where they have like a plus on the 0 like this, I don't know if you can see that, it's really tiny. Or imagine a plus on the upper right, like an exponent, like a plus sign. If you see that, that means they want to know what's the limit from the right only. And that would be 0, and it does exist. If they say minus, they mean the left, you would say 1, and that's the answer. But if they don't have a symbol, they want to know the actual limit, and that does not exist. We'll talk about that soon. Okay, this guy, I'm going to skip this one unless you have a question about it. Number 10. All right. You use a graph of the function f to decide whether the value of the given quantity exists. Okay, so part A, do you remember what this notation meant? What does this mean?
Is it the y value?
Yeah, basically the output, right? You plug in a 1, and then you get an output. So the output is the y value. So what happens when you put in 1? 1's right there, right?
Mm-hmm.
Right. So the output is 2. Now this one is asking for the limit as we approach 1.
There is no limit.
No, it doesn't look like it, right?
Right.
From the right side, we're going to
1, but from the left side, we're going to 4. Those are two
yeah,
different spots, so the limit cannot exist for B.
does not exist. That's right. C, there's a hole, right? Open circle.
Yeah, and they only accept close circles for vertical limits.
So when you have an open, that means it's not defined at this particular place.
Yeah.
But this still satisfies the definition of a function. But right here, it's open. Therefore, I cannot plug in the number 4.
Right.
So the input has no output. It does not exist. But the limit exists as we approach
Yes.
4.
Yes, it does.
I just want
Oops,
to clarify the
actually,
quote.
it was this circle. My bad. Sorry, go ahead.
I just wanted to get some clarification. Closed outputs do not count as a limit, but open outputs don't count as a limit, but closed outputs do.
No, it doesn't matter if it's open or undefined or whatever. The limit could exist, but the functional value itself, I can't plug in. But I meant to say this one. This is the wrong one. Right here. If I plug in 4, it's not defined. At see what I mean? F of 4 does not exist. It's blank.
Okay.
But the limit exists. See, as I approach it, I'm approaching 2. So it really wants to be 2, but there's a hole by definition, therefore does not exist.
And I was
Does
just
that make
wondering because
sense?
number 6 did, I believe that one had an open hole and it still had a limit, but this one doesn't. But this one,
Yeah, this one has a limit, but it's not defined there. For number 10. Number 6, let me see what
yeah.
you're talking about. So this one was defined over here. And the limit was also defined. So this one was defined in both cases, but they were not equal to each other.
Okay, okay.
Does that make sense or
Yeah.
okay. I'll leave this one to you. Do you all have any questions on the ideas? Do you understand what it means to find a limit graphically or analytically?
Yes.
You understand that a limit could exist even if the function is not defined at that spot.
Yes.
Can you do it with numerical, graphically, or with formulas?
Yes, we can do it.
That's 2, 2, and 2, 1. Excuse me. Okay. 2, 3. This one will be analytically, so we'll be using algebra to figure these out. So maybe next time we'll do these two and be ahead. We'll see. So for your homework, I want you to watch the 2, 3, and 2, 4 videos as soon as you can. And if you want to work on them, cool. And we'll talk about them again next time I see you.
Okay.
Do y'all have any questions on anything you were stuck on or in general? Orientation questions?
I have a question.
Mm-hmm.
Did you get attendance?
Not yet.